This is Physics Chapter 2, Problem 43, and it reads, a simple model for a person running the 100-meter dash is to assume the sprinter runs with constant acceleration until reaching top speed, then maintains that speed through the finish line. If a sprinter reaches his top speed of 11.2 meters per second in 2.14 seconds, what will be his total time? So to start this, we have to start by finding his acceleration. And the acceleration we're going to use is change in velocity over change in time. And so his initial velocity was 0, and his final velocity is 11.2 meters per second. So that's what we're going to write. And then his change in time, it said, was 2.14 seconds. And that gives us 5.23 meters per second squared. And then after that, we have to use the equation. X equals the initial position plus the initial velocity times time plus 1/2 times the acceleration multiplied by time squared. And so when we plug in our values, the initial position of x is 0, and the initial velocity is also 0. So we just end up with acceleration multiplied by time squared over 2 if you do the 1/2. So after that, we need to plug in our values. So our acceleration was 5.23 meters per second squared multiplied by our time, which was 2.14 seconds squared over 2. And that gives us that he ran 11.98 meters while accelerating. Okay, so the 11.98 meters he ran while accelerating, we now have that. So now we can use the equation velocity equals change in position over change in time. And since we're solving for time, we're going to rearrange it to get time equals change in position over velocity. So once we plug in our values, we have our change in position is 100 meters because that's what he's running, and the 11.98 meters he ran while accelerating over the 11.2 meters per second, because that's the velocity he's running at, and we get 7.86 seconds. So that's how long it took him to run the remaining time. So the total time it took him to run the 100 meters is 7.86 seconds plus 2.14 seconds while he was accelerating, and we get 10 seconds.